How many ever steps you are taking, that does not matter at all. So here, what I thought, okay, personally speaking, what I thought is I could write sec raised to 4 into 1 minus sine raised to 4. This was my idea. Writing sine raised to 4 as sine square the whole square. Is it wrong if I write it so? No. Sine raised to 4 can be written as sine square the whole square minus 2 tan square. Now this is equal to sec raised to 4 into 1 minus sine square the whole square. I can also write 1 as what? 1 square, isn't it? So it's looking like 1 square minus sine square the whole square, which is nothing but a square minus b square form. And you all know how to factorize a square minus b square. It is a plus b into a minus b, right? Online students, please pay attention here. So a plus b would be 1 plus sine square into a minus b would be 1 minus sine square, isn't it? Then put the minus sign and then 2 tan square. This is equal to, you all know what is 1 minus sine square. You all know what is 1 minus sine square. How much it is? It is cos square. How much it is? Cos square. So sec raised to 4 into 1 plus sine square into cos square. And then here you have 2 tan square. Now this is equal to. Now, how to simplify this whole expression? How to simplify this whole expression? Did you notice you have sec function and cos function here? What is the relation between sec and cos? What is the relation between sec and cos? They both are reciprocal functions to each other, isn't it? And you all know the product of the reciprocal functions is always equal to 1. It's a fact. The product of two reciprocal functions is equal to 1. Now you notice this. You have sec raised to 4 here and cos raised to 2 here. I will do that rough calculation here and show you. Children, you are having sec raised to 4 multiplied by cos raised to 2. Okay, I'm just bringing sec raised to 4 and cos raised to 2 together. Children, don't you feel cos square is, or cos square can be written as 1 upon sec square? Just because cos and sec are reciprocal function to each other, we can write it. So sec raised to 4 into cos square becomes sec raised to 4 into 1 upon sec square. So in the very next step, what will happen? Sec raised to 2 and sec raised to 4 will get eliminated. And what is left over? Only sec square is left over. If you don't want to mess up with your fair calculations, use the rough side of the page. Do all the rough calculations. Whatever result you are getting from there, you bring it here. Okay, so from here I got sec raised to 2. And what is left over? 1 plus sine square minus 2 tan square. This is equal to sec square into 1 plus sine square. Children, what I'll do is I'll open the bracket. Okay, this is my method. If somebody else is teaching you the same sum, they may use sec square is equal to 1 plus tan square or something else they may use. As long as your identities are correct, it does not matter. Okay, what I thought is I will open this bracket. Sec square into 1 is what? Sec square. Sec square into sine square. Children, take the rough page and see what is sec square into sine square. You all know sec square is nothing but 1 upon cos square, just because sec and cos are reciprocal function to each other. So can't I write this as sine square divided by cos square? Wait a minute, I'll show it again. Sec square is what? 1 upon cos square. So it becomes 1 upon cos square into sine square, isn't it? 1 upon cos square into sine square. Now what is 1 upon cos square into sine square? It is sine square upon cos square, isn't it? And what is sine square upon cos square? Quotient relation. It is tan square. Yeah. So you got the answer for sine square by cos square, which is tan square. So I will write here tan square minus 2 tan square. Okay, minus 2 tan square. Joshua, what is tan square minus 2 tan square? Okay, tan square minus 2 tan square, how much? Joshua, what is 1 minus 2? Minus 1. No. So it is minus tan square. What is sec square minus tan square? Inju. Sec square minus tan square. Sec square minus tan square. Sec square minus tan square ready. Sec square minus tan square is equal to 1. Is this the required RHS? This is the required RHS. Okay. It was very easy, just that a little complicated, right? A bit lengthy. Practice it, children. You try to figure out your own method to solve this sum. What, Munish? Will you do it? Yes. Oh, okay. Let's do the second sum. Yeah. Question number 2 for the day. Aditya, solved it? Caitlin, please send it once you're done. Maria, send me the answer. Caitlin, you also. Hussein, Ron, Rian, Gopika, keep the cameras on. Afnan, Aditya, keep the camera on. Afnan, in between, where do you go? You will attend one class, then you will take a leave for 3. Huh? Where do you actually go in between? Are you working in Discovery or National Geography? Huh? Okay, Maria. So where do you actually go, Afnan? I haven't seen such a busy student in my life. And so many wedding happens in your family. How many brothers and sisters you have? Huh? Huh? You don't have no wedding. Monday onwards, you better come for the class. I'll be here by 5 o'clock. Okay, I'll keep the institute open. Yeah. And even if there is any wedding, please request your cousins to not get married till your exams are over. Okay? Seriously, man, you will come for one day and the other days you are absent. You come on Monday. This emoji I will only change, okay? Okay, Afnan, please do come. Your board exams are very near. That's what I'm telling you. All right. Offline students, are we ready with the answer? What do you think the experiment of there are plus losses will become labor again. Plus losses again. Are we done? Who solved it? Hussein, 8 o'clock. Purva, done. Very good. Okay, Caitlin, Maria did it. Okay. Gopika proved it. Good job. Pavish, Salim, Aditya, Afnan, what about you guys? Aditya, okay, fine, Aditya, I'll do it. I'll do it. Ron, Amal, you couldn't solve the first one also today. Angel, go attend the call and come. Priya and Gopika, Shazia, what about you guys? Sorry, did not get. I'm not getting the answer. Pavish, okay, fine. Time is up. Now all of you look at the screen. Afnan, you please watch all the recordings, okay? Fine. So this is the question: 1 upon sine plus cos plus 1, 1 upon sine plus cos minus 1. I will tell you how I perceived it. Okay, I just considered sine plus cos as A and 1 as B. So it looks like A plus B form. And then I considered sine plus cos as A, 1 as B. So this became A minus B. So isn't it looking like A plus B into A plus B and A minus B form? It is looking like A plus B and A minus B, isn't it? Huh? Am I right? Sine plus cos is considered as A. 1 is considered as B. So that entire expression can be compared with A plus B. Okay. Similarly, other one becomes A minus B. Now you will understand in a short while why did I do this assumption. It's quite obvious now when you have two denominators, you will apply LCM method, right? So what is the LCM of sine plus cos plus 1, sine plus cos minus 1? It is going to be the product of these two. So that is sine plus cos plus 1 into sine plus cos minus 1. No doubt in this. I hope you all did this step. Sandra, Sia, we all did this? Fine. The numerator. Now comes the numerator part. You have to apply the LCM method. So take the LCM divided by the first denominator. So sine plus cos plus 1. Sine plus cos plus 1 will get eliminated. What is left? Sine plus cos minus 1. That will get multiplied to the numerator. Hence, getting sine plus cos minus 1. Agreed? Then put this plus sign over here. Again, apply the LCM method on the second denominator. So sine plus cos minus 1, sine plus cos minus 1 will get eliminated. What is left? Sine plus cos plus 1 is left. This is equal to. Now you have to start simplifying it. Children, minus 1 plus 1 cancel. Sine plus sine gives you 2 sine. Cos plus cos will give you 2 cos. Whole divided by. Now, as I told you in the beginning, it is a plus b into a minus b. Don't you agree? This is a plus b. And this is a minus b. And what is a plus b into a minus b? Joanne, I asked you this question. A plus b into a minus b is what? A square minus b square. So let's write that in this form. Sine plus cos the whole square minus 1 square. When I was just walking, I just saw everybody doing this. You are multiplying sine cos 1 within both the brackets. So it becomes a very huge expression, children, isn't it? So better you avoid doing that. Directly you apply a square minus b square form. You see what is going to happen. Anyways, 2 sine plus 2 cos. You can take 2 as a common factor. So 2 comes out and sine plus cos remains inside the bracket. Divided by sine plus cos the whole square. Isn't it looking like a plus b the whole square? Yes. And you all know a plus b the whole square is sine square plus cos square plus 2 sine cos. Minus 1 square is what? 1 itself. Now this is equal to 2 into sine plus cos whole divided by, what is sine square plus cos square? Exactly. Sine square plus cos square is 1. So 1 plus 2 sine cos minus 1. In the very next step, there won't be any change in the numerator. Just keep it as it is. 2 times sine plus cos whole divided by, what will happen with this 1 and minus 1? They both will get eliminated. So what is left? 2 sine into cos. In the very next step, you can cancel 2 and 2. Isn't it? You can cancel 2 and 2. So what is left? Sine plus cos whole divided by sine into cos. Online students, if you have any doubt, please interrupt me and ask your questions. Okay, don't wait for the end. Okay. Now, is this the required answer? No. We needed sec plus cosec, isn't it? So you learned a method yesterday, individually dividing the numerator with the denominator, isn't it? Anuki, help me. Sine divided by, recorded video. Sine divided by sine into cos plus cos divided by sine into cos. What will happen next? Sine and sine will get cancelled. You will get 1 divided by cos plus cos and cos will get cancelled. 1 divided by sine. What is 1 by cos? 1 by cos is sec and 1 by sine is cosec, and hence you get the answer. This is the required RHS. Easy. Alvin, local version, Milan, you all are going to sit back today after the class. I'm going to give you the same sums to do. Okay, but without looking into the book. You will complete it and then leave. You heard it? Yeah. Let's start with the next one. If you are not able to do this, I'm going to give you nicely. Yesterday, I taught you how to do the factorization of a cube plus b cube. Remember? Remember a cube plus b cube. What is a cube plus b cube? It also matters, no, okay. Aditya, solved it? Purva,
Yeah, so I'm
Caitlin,
done.
Maria.
I'm done.
Done, very good. Salim, Hussein, Afnan, Riyan, Amal. Amal, what happened today? You're not sending me the answers. Okay. Children, time up. Now look at the screen. All of you. Maria, you also didn't solve. Still doing it. Okay. Is there anybody who solved it? No one. This is a very important sum, children. Okay. Now pay attention. See here. Today, still trying it. Okay. Okay. You have a hope that you will get the answer. Okay. Hope is everything. All right. Now, children, pay attention. The left hand side is equal to, Ria, did you solve it? Ria?
Sir, even I didn't get it. I'm stuck.
You are also stuck. Okay. So we'll do it together. Now pay attention, Milan. Arthur, look here. Sine cube plus cos cube. I was repeatedly asking you what is a cube plus b cube form, isn't it? Now, without knowing that identity, you won't be able to solve this sum. So a cube plus b cube is a plus b into a square plus b square minus ab. And this is one portion where children do mistake. Instead of minus ab, they put plus ab. And everything will be in a mess. Okay. So please write down this identity again in your book and put it within a box. It's very important. Otherwise, how will you solve this sum? So sine cube plus cos cube. Sine is a, cos is b. A cube plus b cube form. So here you will get sine plus cos into a square, that is sine square, plus b square, which is cos square, minus a into b, that is sine into cos, whole divided by sine into cos. Now, you cannot do it. What is it? What? Oh, acha, oh, you have further. Okay, okay, okay. Plus sine into cos, right? Only this much. Now, this is equal to, can you do anything with sine plus cos? Nothing you can do, right? Yeah. So let it be here as it is, sine plus cos into, what is sine square plus cos square? You all know it is equal to 1, right? Sine square plus cos square is equal to 1. So I will write 1 minus sine into cos, then whole divided by sine into cos, then plus sine into cos. Easy. Now what to do next? Shall I do one thing? Shall I divide sine plus cos with sine into cos? Will I get some result? No, I think. Or shall I apply LCM method? What to do? LCM method? Will it help us? C minus 1. What is the end result that we need? It is equal to 1. No? Okay, that means elimination is going to happen. Children, I'll do one thing. I will first of all try to divide. Okay, it's just a trial and error method. We may get it, we may not get it. If we are not getting, we will go for the second option. Okay, so I will not touch this sine plus cos. Instead of doing that, I will individually divide the terms in this numerator with this denominator. So 1 upon sine into cos will become what? Cosec into sec. Am I right? 1 upon sine into cos is what? Cosec into sec. Reciprocal functions minus Children, sine into cos upon sine into cos is what? 1. Because sine, cos will get cancelled and you get -1. Am I clear with that? I very clearly told you that I'm dividing the terms in the expression 1 minus sine cos with sine cos. Okay, so this is what I'm getting. Put the plus sign and then sine into cos. Okay, Janice, is it clear? No. Those who couldn't understand this, I will do it once again. Children, I am dividing the terms in this bracket 1 minus sine cos with the denominator sine cos. So what will happen? 1 will get divided with sine into cos minus sine into cos will get divided with sine into cos. Now is it clear, Janice? Yeah. Plus, don't forget to mention sine into cos. All right. Now things are clear. Online students? Yeah. Now let's write sine plus cos into. Acha, what is 1 upon sine into cos, Milan? What is 1 upon sine into cos? This one. Cosec into sec minus. Here what you will get? Sine. Here you will get 1. Again, put the plus sign and then sine into cos. We'll do one thing. We'll open the brackets. So how will you open the bracket? First, you will multiply sine with cosec into sec. What you will get when you multiply sine with cosec into sec? Can somebody answer it? Sec, isn't it? I think it is sec. Okay. Again, have a doubt? Do it in the rough page. Children, I am asking you to open the bracket. So sine into cosec into sec. You know sine and cosec are what? Reciprocal functions. And the product of two reciprocal function is 1. So you get 1 into sec. That is equal to sec itself. Make sense? We are just giving it a try, children. I don't know whether we will get the answer. So you're getting sec. Put the plus sign. Sorry. Sine is getting multiplied with what? -1, isn't it? So you get minus sine. Minus sine. Now, multiply cos with cosec into sec. What do you get? Cos into sec is 1. So you will get cosec. Okay. Then cos is getting multiplied with -1. So you get minus cos. And then you have plus sine into cos, isn't it? You have plus sine into cos. Let me write it here. Plus sine into cos. Is it helping out? No? No. We'll do one thing. Since we know that we haven't gone wrong anywhere. I'm sure, right? We haven't gone wrong anywhere. Let's try 2 more steps. Let's try 2 more steps and see whether we can reach out the result. I have an idea, children. Let's just convert sec and cosec into sine and cos. So sec can be written as what? 1 upon cos minus sine plus cosec can be written as 1 upon sine minus cos plus sine into cos. Okay, this is equal to. Now, since you have cos and sine as the LCM, let me just try out, children. Let me just try it out. This is sine minus. plus sine square cos square.
Sir,
Yes, Maria.
sir, we would have gotten the same thing if we hadn't individually divided sine and cos with 1 minus sine cos and directly multiplied sine plus cos with it.
Same thing. Okay. So this is not working out for us. If this does not work out for us, what to do next? Think over it, children. Let's figure out. If we keep trying, we will get. Everybody. Sachin, do something, man. Keep trying, children. We will get. Because we are not wrong anywhere.
Sir, like,
Huh.
yeah, I'm not sure if it's correct. It's probably wrong, but then like, yeah, in this step where we've written sine plus cos multiplied by 1 minus sine into cos plus like somehow if you are able to cancel that sine into cos, like sine plus cos is this. So like since the numerators are same, if we cancel sine with sine into cos, there sine if we cancel with sine with plus cos, and then like we cancel both the sine and cos over there, and then like and brackets will be removed. So then like sine mine 1 minus sine into cos plus 1 plus sine into cos. So like those both will cancel, and then you like get the answer is equal to 1.
Do one thing. Priya, just give it a try, no? Just give it a try and send me the pic.
Okay, sir.
Yeah. Joshua. Sine plus cos is common in both. Will it help us? So this is sine into cos and sine plus cos. Oh, this is sine into cos. Keep trying, children. Alvin. We'll check. We'll just check whether the question is wrong or right. Where is it? What is the question number? 8 first part. Question is right. Sine cos sine. It's correct.
Sir, I sent it to you.
Any idea? Ria, you said something.
I've sent it to you. I'm not sure if it's correct.
No, Ria. That way we cannot cancel. Some method should be there, no? Let me check whether there is any mistake in the question. Are we just canceling it? Oh, children. Listen. So sorry, there was a mistake in the question. Children, this wasn't sine into cos. This was sine plus cos, okay? So sorry. This is a printing mistake. It's sine plus cos. Hey, don't blame me. What will I do? Sorry. Array, children, listen. What will I do? They had given. What? Sorry, children. See, they had given it in this form, no sine into cos. What we could do, isn't it? So it was sine plus cos. Now it's very easy, children. Sine plus cos. Hey, boys and girls, listen. What will happen next? Sine plus cos will get eliminated, right? Yeah, now it is very easy. Sine plus cos will get cancelled. So next will be 1 minus sine cos plus sine cos. Shit, Chumma wasted 5 minutes. 1 minus sine into cos plus sine into cos. Isn't it? Now these two will get eliminated. The answer is what? 1. Okay, next question. Yeah. What happened? We should be doing the next sum. Do the next sum. Children, question is on the screen. Byju's also started giving me trouble. You want me to solve it, then check and tell you the question is correct. Do it, do it, do it. Do it fast. Ron, Kate, did you all copy the previous answer? Gopika, Riyan, Amal?
Yes,
Did you
sir.
all do it? Why your cameras are off, children? Okay, Amal. Salim, Hussain, did you copy it?
Yes, sir.
Yeah. Yeah. I'll come to your place to check your progress. Hussain, keep the camera on.
Hello. Hello. Hello, sir.
How many of you solved it? Maria? Only Maria. What about Purva, Ria, Caitlin, Salim, Aditya? Aditya solved it? I'll come there.
Also, I'm doing it.
I'll
I'm
come there
doing
to
it.
check. Still doing it. Gopika, Riyan, very good. Salim. Time is up. Girls, this side. I'll come, boys. Wait a minute. Boys, what about you guys? Monish, sorted? No. Sachin? No. Pay attention, children. Everyone, look up. Everyone, look here. Are we all taking the LHS? So you get sec minus tan the whole square multiplied by 1 plus sine. Now this is equal to sec minus tan the whole square. Did you apply a minus b the whole square identity? Yes. So what is a minus b the whole square? A square plus b square minus 2ab. So you get sec square plus tan square minus 2 into sec into tan. Isn't it? Close the bracket and then write 1 plus sine. This is equal to sec square plus tan square. Is it equal to 1? No, right? Yeah. Then shall I convert this into sine and cos? Because if you notice the right hand side, it is only sine, isn't it? So I'll do one thing. I'll try to convert this into sine and cos. Sec square is what? 1 upon cos square. Tan square is what? Sine square upon cos square. Just a minute. Minus 2 into sec is what? 1 upon cos. Tan is sine upon cos. Let's give it a try. Into 1 plus sine. Before that, I'll just confirm whether the question is right or wrong. It's correct? Oh, you got it? Okay. Fine, children. Now I'm really scared, I just can't afford to waste time. Yeah. So 1 upon cos square plus sine square upon cos square minus 2 into sine upon cos square. Children, if you notice, 1 upon cos square plus sine square upon cos square minus 2 into sine is 2 sine divided by cos into cos is what? Cos square. Okay, so far everything is going fine. This is equal to, what should be the LCM inside the first bracket? What should be the LCM? Cos square, isn't it? So I'll write here, cos square. So the numerator will become 1 plus sine square minus 2 sine into 1 plus sine. 1 plus sine square minus 2 sine upon cos square into 1 plus sine. Achha, I have a question for you. Children, what should be 1 plus sine square minus 2 sine? Isn't it 1 minus sine the whole square? Yeah, it is the expansion of 1 minus sine the whole square. Don't you feel so? Children, I will take some separate space and show that. Okay, look here. What is the expansion of 1 minus sine the whole square? It should be a minus b the whole square expansion. It's a square plus b square minus 2 into 1 into sine, which is 2 sine. What is 1 square? 1 plus sine square minus 2 sine. Are we getting the same expression over here? Over here, 1 plus sine square minus 2 sine? Yes. So all of a sudden that calculation should come into your mind, children, which I always say, through experience it will come. Okay, so 1 plus sine square minus 2 sine is nothing but 1 minus sine the whole square. All right. So I'm having a hope that we will get the answer. So 1 minus sine the whole square, whole divided by cos square into 1 plus sine, right? Into 1 plus sine. Now, this is equal to one minus sine the whole square upon cos square into 1 plus sine. What we can do next? I think we can write this as 1 minus sine upon cos the whole square into 1 plus sine. Is this correct? 1 minus sine upon cos the whole square into 1 plus sine. What is the final answer that we need? 1 minus sine, isn't it? Okay. Children, I think this would be a bad idea. This is a bad idea. This is a bad idea. Why don't we write cos square in terms of sine square? Don't you agree with that? This cos square can be written in terms of sine square. No, 1 minus sine square. Do you all agree with that? So let's take 1 minus sine the whole square divided by 1 minus sine square into 1 plus sine. Okay. Now this is equal to, children, 1 minus sine the whole, sorry, 1 minus sine square. Can't I write it as 1 minus sine into 1 plus sine? Because it is of the form a square minus b square. Are you getting my point? Bottom one. Bottom part, children. 1 minus sine square, isn't it? Isn't it looking like 1 square minus sine square? Hello? Am I right? 1 minus sine square is what? 1 square minus sine square. And this is exactly a square minus b square form, which is giving you 1 plus sine into 1 minus sine. Can't I use this? So let me use that. 1 minus sine the whole square divided by 1 plus sine into 1 minus sine. And then again into 1 plus sine. So what will happen next? 1 plus sine gets eliminated. Now what is left? 1 minus sine the whole square divided by 1 minus sine. Right? Again, we can cancel. 1 minus sine the whole square is what? It is 1 minus sine into 1 minus sine divided by 1 minus sine. Can't we cancel 1 minus sine, 1 minus sine? Yes. And that is equal to 1 minus sine. This is the required RHS. Children, from this step onwards till here, till the final step, it went a little lengthy. But if you people are good with calculations, you're good with eliminations, you can even do it in your mind. Isn't it? Here I have to show you one after the other. 1 minus sine square is what? 1 square minus sine square. And what is it? 1 plus sine into 1 minus sine. So when I'm explaining it, it takes a lot of time. Okay, but when you people will do it in the exam, it won't take much time because you all would have practiced it rigorously. So when you're sitting for the board exams, automatically it will strike your mind, right? It should strike your mind. Otherwise, after exam, I'll strike you. Okay, yeah. Children, next sum. I expect you to solve at least one sum on your own, children. Every other sum, I am only helping you. What is this? At least do this. Tomorrow evening, 5 o'clock, huh? Class. Tomorrow evening, 5 o'clock, Sunday. Do it fast. See the right hand side, children. They have given you the right hand side in terms of sine and cos. The left hand side is in terms of tan, cosec, and sec. So you all know how to convert tan into sine and cos, cosec into sine, sec into cos, isn't it? Apply the reciprocal functions here. Do it, children. Do it. Do it. Aditya, you followed the previous sum.
Yes, I followed it.
Okay. Sachin? Riyan, Gopika, Hussain, Afnan. Did you all understand the previous sum?
Yes, sir.
We done, children? Online students? Nobody solved it? Caitlin, Priya, Purva, Maria, Aditya? No. Salim, stuck. Ron, Rian, nobody. Gopika, Afnan. What man? Okay, Purva, still trying. Caitlin, still trying. Gopika, still trying. How many of you solved it? Ready? The answer is correct. Okay, fine. Anyways, let's check. So I just pray that the question is not wrong. I don't want to get all the curses from you. Seriously. Okay, fine. Let's take the LHS is equal to tan square upon tan square minus 1 minus cosec square divided by sec square minus cosec square. And when you look at the right hand side, it is 1 upon sine square minus cos square. So I think you should be converting the left hand side functions into sine and cos, isn't it, Milan? Let's write tan square as sine square by cos square divided by tan square as again sine square by cos square minus 1 minus cosec square is what? 1 upon sine square divided by sec square is what? Anika, sec square is what? 1 by cos square, and cosec square is what? 1 upon sine square. Okay. Now this is equal to, let's take the LCM. All right, I'll not touch this sine square by cos square. I'll do one thing, children. I will apply LCM method in the denominator. Okay. I will apply LCM method in the denominator. So cos square will become the LCM and the numerator will be sine square minus cos square. All right, put the minus sign. Now 1 upon sine square whole divided by, now 1 upon cos square minus 1 upon sine square. What is the LCM? Sine square into cos square, right? The LCM is sine square into cos square. Good job. Now apply LCM method. So the numerator will become sine square minus cos square. I'm directly doing, believing that you people know how to apply LCM method. Okay, basics. Now children, from here, why can't we just cancel cos square and cos square? We can cancel it. So it becomes sine square divided by sine square minus cos square minus. And here, sine square and sine square will get cancelled. So cos square is left, no? So it's like 1 whole divided by sine square minus cos square. What happened? I'll write it in the next step. Oh, you want to directly write it? It's correct? Now it's correct? Cos square upon sine square minus cos square. Yeah. Now again, what is the LCM? Sine square minus cos square. So the numerator will become what? Sine square minus cos square. It is wrong, children. Wait. Let us not waste time. Check the question. Even I'm getting 1, but let me see what the question is. What was it? This is done. This one, no? This question, right? This one, right? Yeah. 9th part 1. Where is it? Oh, it's the third one, right? Yeah, it's the third one. Yeah. See this? What happened? Plus what? Achha, so what was it? Oh, we have minus. Oh, okay. Sorry, children. Listen. Hello. Children, again, there is a mistake in the question. It's plus sign, okay? Hey, there is no much damage like the previous one. Children, instead of minus, it is plus. Now do it. Instead of minus, it is plus. So sine square plus cos square is what? 1. So 1 upon sine square minus cos square. All right. Children, did you all understand? We did it perfectly. Just that the question was wrong. Instead of plus, it was minus sign. So once you got plus sign, sine square plus cos square became 1, isn't it? Yeah. One last sum for the day. Got it? Yeah, one last sum, children. Yeah, do it fast. Just a minute. I'll just check whether it is right or wrong. Which one? Which question is it? Children, just wait on. Don't start solving. This is the 9th one. Don't do this sum, children. Don't do this sum. Don't do this sum. No, it's correct, but don't do it. They will not ask you such questions. Yeah, this one. Start. Why there is so much of noise today? First you show that this is equal to this, then this is equal to this, then this is equal to this. 3 sums together. Do it. After? Start doing it. Do it. I know it's a weekend, but you can't behave like weekend does, right? 6 to 7 marks. 6 to 7 marks. This will. Am I preparing the question paper? No idea. No idea. So, children, rather than discussing that, solve the sum. Do it fast. My dear children, at least show that the first 2 expressions are equal. Okay, sine plus cos by sine minus cos plus sine minus cos is equal to 2 upon. Salim, did you do the previous one? Hussein?
Yes, sir.
Okay. Riyan, Gopika? Maria, you also did the previous one, no? Just that there was a mistake in the question. Okay. Yeah. Aditya, you rectified it, no? Instead of minus, it was plus. The first one and the last one is solid. First one and the First you solve the first and the second one, then we will think about the last one, okay? Are we done? Maria, no. Purva, very good. First one. Very good, Gopika. First two. Then who else? The last one. No? Okay, I'll help you. Done? All the three? Okay. Done? Good job. Now, children, please give me some time to explain this. Hello, Sandra. Listen. See you, all of you. Pay attention. The first part, you must have taken sine plus cos divided by sine minus cos plus sine minus cos upon sine plus cos. This is equal to, obviously you must have applied the LCM method. So the LCM here is sine minus cos into sine plus cos. Okay. Let's apply the LCM method. Take the LCM divided by the first denominator. So sine minus cos will get eliminated. What is left? Sine plus cos is left. So sine plus cos into sine plus cos is what? Sine plus cos the whole square. Similarly, take the LCM divided by the denominator. So sine plus cos is eliminated. Sine minus cos into sine minus cos will give you sine minus cos the whole square. Now this is equal to, children, do you remember this identity which I taught you in class 9? The one which I taught you day before yesterday, you don't remember. Now listen, everyone. Children, what is a plus b the whole square plus a minus b the whole square? Do you remember it? I've taught you this in class 9. A plus b the whole square plus a minus b the whole square. It is equal to 2 times a square plus b square. If you want to save time in your board exam, please learn all these identities and go. Okay, note it down. Note it down. A plus b the whole square plus a minus b the whole square is equal to 2 times a square plus b square. So you can very simply solve the sum. 2 into a square plus b square. What is a here? Sine. So sine square plus b square, that is cos square, divided by denominator is what? A minus b into a plus b, that is a square minus b square. So you get sine square minus cos square. This is equal to, what is sine square plus cos square? It is 1. So 2 into 1 divided by sine square minus cos square, which is equal to 2 into 1 is what? 2 itself upon sine square minus cos square. Easy. So this you got. Now you had to show this is equal to what? 2 upon 1 minus 2 cos square. Now that was quite easy, children. 2 upon, can I write sine square as 1 minus cos square? Yeah. So it becomes 1 minus cos square minus cos square. That is equal to 1 upon 1 minus 2 cos square. Huh? Oh, it's 2. Achha, sorry. It's 2, children. 2. 2 upon 1 minus 2 cos square. So the third part is also done. Priya, did you follow it? Okay.
I
Very
did
good.
till
Amal,
this
Purna,
part.
till this part. Okay. Now the last part is remaining. No? 2 sec square upon tan square a minus 1. All right. Please pay attention. As of now, you have got 2 upon 1 minus 2 cos square. And they are asking us to prove, listen to this. They are asking us to prove 2 upon 1 minus 2 cos square a is 2 sec square upon 2 sec square upon what? Tan square a minus 1. Okay, this is what they are asking us to prove. Children, so what happened all of a sudden here? In the numerator, were you having c square? No. But on the right hand side, you are having c square, isn't it? Shall I do one thing? Shall I take the LHS? Just a minute, huh? 2 upon 1 minus 2 cos square. This is what you have as of now. Children, shall I do one thing? Shall I multiply the numerator and denominator with sec square? It's permitted, no? Oh, you took the RHS. 1 upon sec square and then 2. Fine, chalo, we'll do that. So 2 upon 1 minus 2. Children, cos square is what? Sec square, isn't it? 1 upon sec square. So it becomes 2 upon sec square. This is equal to 2 whole divided by, now here you are having c square as the LCM. So let me write sec square in the denominator. Sec square into 1 is what? Sec square minus 2. Now this is of the form a whole divided by b by c. It is of the form a whole divided by b by c, which is a into c by b. Let's apply this. 2 into sec square divided by sec square minus 2. Is this the result? No, because in the right hand side denominator, you need what? Tan square minus 1. Very easily you can bring this. The numerator is 2 sec square whole divided by. Can't we write sec square as 1 plus tan square? Sec square is what? But either easy. C square is 1 plus tan square minus 2. This would be easy, I think. So 2 into sec square divided by, what is 1 minus 2? Minus 1. So you get tan square minus 1. This is the required result. Followed? Followed it? But you people are still not ready for the exam. Because every other sum, hardly 2 or 3 sums you solved. The remaining sums, you needed my help. Okay. Huh? Now you point out that. Okay. Shall I give you one more question? No. Then. All right. Now don't make noise. Listen to me, children. I am not very satisfied with the way you have performed. Okay. Now, anyways, tomorrow we will start with mensuration. Trigonometric identities, whatever is important for the boards, we have done. And even for your prelims, I mean the second split up, we have done enough and more sums. Okay. Now, children, tomorrow we will start with mensuration because that is a very lengthy chapter. Last year, they had reduced the portions from mensuration. There was no sphere and hemisphere. So we had to do only 2 exercises. Since that is now, since the council has, regained those deleted portions, we have to do all the exercises. And since these 2 sections have been introduced back again, it's going to be very lengthy. Okay, because there are varieties of sums which we have to solve in spheres and hemispheres. All right, so that is going to take 1 whole week or even more than that. Now you all have the exam on November 7th, isn't it? Today is what, 29. So we hardly have 1 week. So whatever is possible from tomorrow till next Friday, we will do in mensuration. I repeat, children, this is how we are going to plan it out. From tomorrow, that is Sunday, till next Friday, we are going to do what? Mensuration. And then Saturday and Sunday, we are going to do complete revision. All right. So in a day, you will be having 2 sessions. In a day, one morning session, one evening session. Sunday also one morning and one evening. Or you want to study on your own on Sunday? No? You want to study on your own, right? Then we'll do one thing, children. Then we will do one thing. Saturday, we will keep 2 sessions. All right. And then Sunday, the whole day, you are going to sit and study at home. But evening time, I will call you for 1.5 hours. Just to revise or just to solve your doubts. Okay, that we will do only if it is required. Otherwise, if you people want to sit at home and study on your own, just do it. Okay, so this is how we are going to plan out next week. All right, fine. God bless you all, children. Thank you so much. Take care. Purva, you also join for the revision sessions. Okay. Yeah. Aditya, you also. Fine. Thank you so much, children. Bye. Take care. Good night. Happy Sunday.
Thank you, sir.
Thank
Good
you,
night.
sir.
Thank you, sir. Bye, sir.
Bye, children.
Thank you, sir. Bye, sir.